At the moment, we would have kick off. I think we'll just go ahead and kick off while others continue to join. The section is also on record, so they can always go through the recording. Welcome everyone. Welcome to NAIJA-JUG, the Nigeria Java User Group. Today is another section of our monthly meeting. And here today we have in the house a very a honorable person in our midst who have been in the industry over the years and have witnessed a lot of changes, updates, upgrades from Java stuff, understand? So here is a lead engineer and also the CEO and founder of OpenJ Proxy here in our midst, and by name, Mr. Rogerio Robetti. We must say a very big welcome to him tonight. You are very much welcome, sir.
Thank you very much. A pleasure to be here.
React with your favorite emoji if you are happy to have him here.
Ah, love the emojis, yeah.
All right, you are very much welcome, sir. Today we have a very important topic here, which is the proxy power, boosting Java app performance with OpenJ Proxy. So let's go Proxy tonight. At this point, I'll be handing over the section to our guest speaker to kind of lead us from this moment. So, Sir Robetti, please, you are highly welcome and you can go ahead and take the floor.
Thank you, Victor. Really appreciate it. And just want to start by extending the thank you for all of you guys that joined today. It's great to have you here. And special thanks to Victor that organized this meeting and invited me to come here and talk about the OpenJ Proxy project and about some modern problems that the OpenJ Proxy tries to address or comes to address, right? Things that were not addressed before. So if you're here, congratulations to you. Like you're one of the few that look for knowledge and surely this session will be productive for you. So if you allow me to, Victor, I will start sharing my screen and I'll share a small presentation with, with you.
Yeah, sure, you can go ahead.
Please let me know when you can see my screen.
All right, so I will do that. I can see your screen very clearly.
You can see it now, right? So let me just
sure.
start the slideshow. I'll be looking to the side because my monitor is on the side here. It's not that I don't want to look.
That's okay.
So the camera is here, the monitor is there. All right, yeah. So today we're going to be talking about the OpenJ Proxy, right? And how can it boost performance and resilience from Java applications. A small agenda for today. So this is what we're going to be talking about. Not going to stay here long. Small legal note, this basically what's said here is that this presentation, as any other contents inside this presentation or anything spoken here, is free to be used. You can use it to present in your company, in your schools, etc. It's just that I'm not responsible if you modify it or if you do something else with the products or the materials that I present here. A short introduction to the partners of OJP. So Comunidade Brasil JUG was the first Java user group that supported the project. So I keep them in high regards. They helped us to start our community and to start engaging with the Java user groups like yourself. I'm from Brazil myself, so that kind of makes sense, right, that you start in Brazil. Switcher API, which is a feature management platform. So if you want to turn on and off features in production in a more structured way, that's the project to go to. It's an open source project as well. And Materian is a scanner for vulnerabilities in open source solutions. So we all use many open source libraries, and you need to scan those libraries for vulnerabilities. So Metarian is a very good option for that. CyberJar is a YouTube channel. If you're not following CyberJar, follow now, because it's the best content for Java. Very clean, very well produced. Like, the guys are doing an amazing job there. Like, you watch one video of them, you're gonna see what I'm talking about. There is nothing like them. They produce very good quality video, audio, content. Like, how they present it is brilliant. So Java Challengers. Java Challengers is another YouTube channel, and LinkedIn page is more focused on career development. So if you're trying to increase your career or improve your career, move your career as a Java developer forward, Java Challengers is your YouTube channel and LinkedIn page. And Omnifish is basically a company that supports and is continuing to develop the Eclipse Glassfish. So if you're thinking of using Java EE, like with Eclipse Glassfish, these are the guys to go to, because they are the developers of the current core developers of Glassfish, and they provide the best support for Glassfish. Okay, so they have been helping our project. We always advertise them because, you know, it's a two-way street. I'll be introducing myself at the end, because I don't want to keep the introductions too long. I want to engage the people early. So let's jump into the technical stuff right away, so you don't slip in the presentation. So very quickly, let's just remind ourselves of a very universal truth in computing systems, that serialization outperforms parallelization. And what that means? That means that we have a limited amount of CPUs, right? And a limited amount of cores means that we can truly do parallelism just about the number of the cores we have. I know that we know that we can turn it more efficiently because there's pauses to read data from the disk or from the memory, etc. But at a very basic level, you cannot do too much parallelism because you have a limited amount of CPUs. If you start doing too many threads, what will happen is that the CPU needs to switch between those threads, and that costs, right? So let's just remind ourselves about this concept, because it's very important in relation to why we should keep connections to a database small, because it starts there. Like, we have a limited amount of resources and a limited amount of parallelism to use. So just a very quick example of a stateless service scaling up in production. So we have our little Spring Boot app there with 20 connections to a database. The database is very happy, right? 20 connections is easy to handle. But suddenly the demand for this app starts increasing. It is programmed to auto-scale on demand and starts scaling up, right? Let's say you have a Kubernetes cluster, or you have this deployed on a cloud provider that can auto-scale it, and it starts to scale up. Once you reach 3 instances, we have already 60 connections with the database, right? And the database is starting getting worried, right? Because connections are rising, demanding are rising non-stop. The database cannot scale elastically, right? Some cloud providers claim it does, but when you read the small letters, it doesn't really. What they do, they over-provision your database, or they do tricks. Database is a stateful system, and it's very hard to auto-scale stateful systems. Now, our service is still in demand. Maybe it's a Black Friday, whatever it is. There is a lot of demand coming to your portal or website, etc. And it keeps adding more instances. By this time, we have already 100 connections against this database. The database is struggling a lot. And in our example here, when it reaches 8 instances of this app, which represents 160 connections to the database dies, right? Because it cannot respond to all that. It's too much parallelism. It ends up having to handle all this context switching, not just at the CPU level, but also at the connection level. So there's too many connections. It needs to handle all these connections, ends up using resources to do this instead of doing work. So it's too much pressure. There is nothing protecting the database against all this pressure. So what came about to help with this situation where you have a system like a database that cannot scale so fast like a stateless application, but that needs to be protected. So people started creating database proxies, right? OJP is not the first database proxy, but we are very different from the existing ones. And we'll walk through what is different there. So what happens is that the OpenJ proxy tries to answer these questions here, right? How can we elastic scale our applications without overwhelming our databases? And we don't want to over provision our database, because that's what some companies do, right? Because they in the peak of their volume or their demand, they need a big database. So they keep a big database all the time, but that is money going down the drain, right? You're spending more money than you really need. How can I make it this new solution compatible with multiple databases and multiple cloud providers? Like, how can I have something that runs in AWS, like the AWS proxy, RDS proxy, that only runs in AWS? But I want the same solution to run in Azure, to run in Google, to run in every cloud, or to run on-premise. And we have also other types of database proxies, like the PG Bouncer. The PG Bouncer is for Postgres, but it works well only for Postgres. Can we have a solution that works for many databases, right? That was one of the questions. How can we achieve high availability without having to employ an external load balancer in front of the proxy? Because let's say if you employ a proxy, a database proxy to protect your database, in traditional systems, if you deploy more than one of these proxies, you need to put a load balancer in front. So you have two more components, right? You have the proxy and a load balancer in front of the proxy. And one of the questions was, can we eliminate this proxy, right? Not need eliminate the load balancer, not the proxy. Can we have a database proxy that doesn't need a load balancer at all to scale and to be deployed in multiple instances? How can we deliver seamless integration with Java apps? How can we make it more open source the existing solutions? There are good solutions, but not all of them are open source. Some of them are private. Can it be developed in Java? We're Java developers, right? So we like things developed in Java because we can look at the code and we understand what's going on. We can contribute. We can make it better. And can we have a connection pool that is as efficient as HIC-RCP? RCP is the full Spring Boot connection pool. Is a loved and trusted connection pool. It's very efficient. So we want to know, can we have a solution that is as efficient as this HIC-RCP? And that's how OJP was born. So in this screen, we can see OJP exactly as it's implemented. It has two parts. One is the proxy itself, that's in the middle there, so the OJP proxy server. So that is the guy that will connect to the database. That's the guy that holds real connections with the database. And it uses normal traditional JDBC drivers, for example, Oracle JDBC driver, MySQL the JDBC driver, and Postgres JDBC driver to connect to the database in these examples. And in this example, in the screen, it opens 10 connections only against those databases. And it keeps that at 10. So it doesn't matter how many connections the client opens. So in this scenario here, it doesn't matter how many connections are coming in. Only 10 connections are open in this example. We'll see another example later that shows how would that look like in this scenario. But basically here we have two parts. So one is the OJP proxy server and one is the JDBC driver. So we created our own JDBC driver. And why did we do that? We did that because we can control the whole functionality of the two in a better way. And that gives us the ability, for example, we can connect the JDBC driver with the OJP server via gRPC connection, which is a multiplex connection. So it's a very efficient protocol, and that we can send many connections or many statements in one pipe, in one connection only, using HTTP 2.0, which is a very fast new protocol, right? So that's one advantage. The other advantage is that we can do load balancing. Remember that we didn't want to have an external load balancer. So we can do load balancer in the driver, and we can do failover in the driver. So if one OJP server dies, the driver can send all the flow to another automatically. So we can do all these things because we produced our own JDBC driver. Also, it integrates easily with Java, right? From the Java perspective, it's just another JDBC driver. So instead of using the Oracle one, you use the OJP one, and you send your normal connection to the Oracle with a small modification that we're going to talk later. And it will go to OJP server, and then OJP server will connect to Oracle for you. Basically here, the main concept here is that the connections to the database remain stable, and the app can scale as much as it wants, and it will create virtual connections then. The OJP JDBC driver gives virtual connections to the app, and those connections are just a channel to the OJP server. And when a real connection is needed, like for example, when you need to execute a query, then a connection is allocated, execute the query, and then that connection is released to the Hikari CP pool inside OJP server to be reused. That's another question answered. Can we have a connection pool as efficient as a Hikari CP? Well, we just use Hikari CP. That's what we did. So we do have a connection pool as efficient as Hikari CP because we are using Hikari CP inside OJP server. Going forward, so in our example here where the database died, if there was a use of OJP server or OJP, the server and the JDBC driver, this is what it would look like, because you could have your 160 connections in the app, but they would be virtual connections. They wouldn't represent real connections to the database. All that pressure would come to the OJP. OJP would queue all those queries to the database, and the database would receive only, in our example, 50 connections. So it would absorb all this pressure, working as a back pressure mechanism. So it defends. That's why we use a shield symbol. It's a defense for your database. It shields your database against these sudden pressures, which sudden pressures can come from like a legit increase in demand, but they can also come from a DOS attack, right? So you may be under attack in a denial of service attack, and this is something that helps you to defend yourself. It doesn't resolve the DOS attack, but it surely helps to mitigate it. It is one of the points that will prevent your system from going down. We also can help with the distributed monoliths. If you're working with microservices, you've probably seen this pattern somewhere, where the company starts breaking down a large monolith into microservices. And they break all the services nicely, let's say orders, billing, inventory, all separated by the domain, using domain-driven design, all those fancy new strategies that we all love. But at the end of the day, they cannot migrate the database, and the database remains a single thing. And then you have multiple services broken into microservices, but still a single database. In those scenarios, OJP can be very beneficial as well, because if we are talking here that for one service, OJP protects the database, imagine a database that needs to serve multiple services, right? So even more important to have some sort of protection in front of that database. If there is any questions, Victor, you can interrupt me and we'll take questions as we go. Don't need to wait for the guys. I forgot to say that.
All right. Okay, guys. Please, if you may have any question, please, what you do, just kindly raise your hands and I will call you in. Thank you.
Thank you, Victor.
Yeah,
and please do ask questions, you know, because I count the questions to see which Java user group is the most, the one paying more attention to my presentation. I'm kidding. Let's move forward. So this is a small graph, Cartesian plan that shows where OJP position itself compared to other database proxies. So this shows which database proxies are open source. So if they are more to the right, they are more open source. If they are more to the left, they are less open source. If they are more to the top, they support more databases. If they are down, they support less databases. And this graph alone shows why OJP had to exist, because we didn't have a proxy solution that could connect to many databases. We have, for example, Proxy SQL that mostly is for MySQL, and now is starting to support Postgres, but it's still only 2 databases, right? Or 2 database families. We don't have anything that supports at the same time Oracle, DB2, SQL Server, Postgres, MySQL, MariaDB, CockroachDB. So we needed something that is different from what existed. And because OJP draws the boundary at the JDBC level and not at the wire protocol level of the database, OJP can support many databases because we use the JDBC driver as our communication protocol with the database. So any database that supports JDBC can be supported by OJP. We currently test and support 7 databases, the ones that I just mentioned. But in theory, it can support any database that provides a JDBC driver. As soon as it has a JDBC driver, it can be incorporated into OJP. And that's, I think, it is great power to have. This is just a few notes in relation to that. So we implement this proxy in Java. It's a layer 7 proxy, meaning it's at the application level. So it doesn't just operate at the protocol level. It understands what is receiving. It can validate. It can do things with the SQL you're sending. We are currently experimenting with Apache Calcite. In the future, it might be even able to improve your SQL. Let's say you send a bad SQL. OJP might be able to improve that SQL for you in the future. Not currently. Currently is experimental. But because it operates at the layer 7, at the application layer, it has the possibility of doing these kind of things. It can do circuit breaking. You can separate fast queries from slow queries. We're going to talk a bit more about that. And we can do many other things. We already talked, is database agnostic. You can support many databases. It's cloud agnostic. You can deploy OJP in the cloud, outside of the cloud, in any cloud, in your home computer. It can be deployed anywhere. You can deploy it as a Docker image or as a simple jar, executable jar. So whatever way you want to deploy it, you can do it. It's not just for Java. It's focused in Java at the moment, but because we use gRPC protobuffers, those protobuffers can be compiled in different languages. So you could use the OJP server with a new client in C# or C++ or any other language that supports gRPC and protobuffers. It integrates very nicely with Java. We talked about that already, and brings an unprecedented freedom to the proxy landscape. We didn't have this freedom before. Like before, if you select a proxy to use, usually that proxy would be for one database or for a few databases in a single cloud provider. It wouldn't be open source. So there was all these problems. Like normally you would be binding yourself to one solution. Yeah.
Okay. We have a couple of questions coming up.
Yeah.
Yeah. The first question is coming from Mr. Dashon Carter. He asked, "Can I have more than one deployed for the same DB?"
More than one OJP server deployed for the same DB?
Yes.
Yes.
Yes, you can. So the OJP server, this server that we show here, that layer there, you can have a cluster of it. We recommend you have 3, minimum of 3. But if you have a demand for 5 or for 9 or for 12, you can deploy a lot more. Yes.
Fantastic. I joined late. I'm sorry for the question that you already answered.
No, I didn't answer. It's a new question.
Okay.
It's a good question.
Thank you
for that.
Yeah, all right. Okay, Mr. Rogerio, can you go ahead and ask your question?
Yes, sir. Good evening, Mr. Rogerio, sir. So my question is, like, does it support R2DBC, like, if you want to do some reactive connection, sir?
Can you repeat the question? Does it support what?
R2DBC. Because, I mean, does it currently support R2DBC?
R2DBC. I don't understand what that is.
Okay, like the R2DBC you are talking about, is it a database?
Is this a database? Maybe can you?
No, it's a different protocol.
You talk about the JDBC connection. So, yeah, like the other version of JDBC is like for reactive connectivity to database. The R2DBC.
Reactive protocol. No, it doesn't. It does not. Does not support reactive connectivity to the database now. I understand that reactive has been a big thing for a long time now, but I have word from big people that it will not be like that anymore, and that's mainly because of a few factors, right? So we got advice not to invest anything in reactive. That might be good information for you guys as well, because reactive, there are a few problems with the reactive programming, right? One of the problems is the complexity. So the teams that migrated to reactive, it's a lot harder to implement and a lot harder to maintain. And the benefit was that you get better performance, right? And you basically use better your threads. But now after Java 21 with the virtual threads, that benefit almost become negligible, if any benefit at all. So there is the possibility of a movement back to not using reactive programming is very big in the Java community, and the indications from some big people that we consulted about OpenJ proxy is that we shouldn't invest anything on that at the moment, because probably people will go away of reactive programming in relation to Java because of this scenario. Like it is complex to get right, it's complex to implement and to maintain, and now with virtual threads and the introduction also of the HTTP 3.0 now that is starting to be introduced with the quick protocol, the benefits of reactive and also to the database, but not just to the database, on the client side as well, from a REST perspective, etc., will decrease a lot. So we didn't implement because of that, and we have no plans of implementing at the moment because of those reasons. But if the landscape changes, obviously we'll change our stance on it. But currently, because of this this rationale, we are not investing anything in the reactive protocol. But it's a very good question. It's the first time I get this question. It works on the traditional JDBC, right? So vast majority of applications still use a traditional JDBC. So we work on top of that. Thank you very much for your question. Very good.
Can I ask one more question?
Yeah.
Is that okay? Like I've seen this presented. I've been eager, and in my head, I've got auto scaling microservices, right? I've got my service A, and my service A is configured with a connection pool, and that the number of connection settings that I want. And then when I scale it up, you know, let's say they all have 10, and I scale up 10, 10, 10, 10, 10. When I'm doing that, I'm not considering the database behind. Am I thinking of this right, where I can now have this proxy that manages to not overload the database while I'm auto-scaling?
That's exactly it.
Is this one of the problems I'm solving?
That's the center problem you're solving. Most database proxies will solve it for you, but again, those solutions they're tied to one database or to one cloud. Now, this is the scenario I think you missed, but really quickly, it's exactly what you described. You increase your replicas of your app until the database collapses, right?
Yes.
If you use a solution like OJP, what happens is all that pressure goes into the proxy, and the proxy handles that pressure and keeps the database safe. So you can always keep the flow to the database stable. That allows you to protect the database from dying, which is the worst case scenario, right? Not being responsive. But also in many scenarios, you can decrease the size of your database, because many companies size their database to the biggest load they expect in a year, for example.
Yes.
Because so they're basically paying for a gigantic database for day-to-day that they don't really need. They just need that big database a few times a year or a few times a month. And that's all because when you grow and your applications scale, that big demand comes and hit all directly the database, and that can cause a lot of trouble. So putting a proxy like OJP in front of it can even save you some money in relation to your database expenses. And especially if it's a database that is licensed, like Oracle or DBT or SQL Server, that as bigger the database gets, as more license you need to pay, right? So that surely helps on the money side as well.
Well, I'm going to tell you a secret. I love saving money. So thank you.
Who doesn't, right? It's something that always bothered me, because especially in big companies, the solution seems to always to throw more money at things, and it's not the best technical solution, right? And as engineers, we like to look at what's the most efficient way of doing something. And the most efficient way is to use the resources as best as possible. And if you're just throwing more hardware, it's surely good for whoever is selling you hardware or licenses, but it's not the best engineering solution, for sure not. So what we're pursuing here in OpenJ Proxy is to provide one of the tools that allow you to achieve a better engineering that actually saves resources in the end of the day, and make it more resilient and more reliable, more stable in the overall system. Moving forward, go ahead.
Sorry for interrupting. Can we take one more question before moving on?
We can absolutely.
All right, Mr. Mushu, please ask your question.
Mr. Rogerio, thank you very much, sir. I want to ask, what is the maximum queue size that OpenJ Proxy can handle, and how does it deal with back pressure? Does it just cut off excess requests? Thank you.
The maximum size it can handle, there is no limit, because you basically can put as many OJP servers as you want. You can put 3, which is the minimum we recommend, or you can put 50. I think 50, probably there is something you need to look into your architecture if you need 50, but there is no limit in theory. What does change, I think this picture helps to understand it. Every application will open one HTTP 2.0 connection against each OJP server. So what that means is that if you have 3 OJP servers, there will be 3 connections open on each application side, right? So if you have 3 applications and you have 3 connections on each of them, that means 9 connections. You can have many connections against OJP servers, but as you grow it, obviously you need to account for that on your hardware. So you should be prepared to have a appropriate hardware. We have some guides in relation to this in our ebook. We have an ebook in our repository. You can check there. And I can quickly show you here where is it. Apologies, I think I don't want to do this like that. Okay. Yeah, so if you come here to our repo, in our documents, there is an ebook here. And I will not be able to find now quickly where is it exactly, but there is a chapter here that tell you how you should size things for OJP. That's a good source for you to start looking at how big it is. And what happens if it overwhelms OJP? Was that second question? Like if it reaches a limit? Was that
yes,
question?
sir. Yes, the back pressure. Yes, sir.
Yeah, the back pressure. So it might reach a limit. It will start timeout. But that timeout is, in theory, a good thing because it's not a database timeout, right? So it means the database is still doing work. It's not a database that is timing out, but it's very hard to time out the proxy, I'll tell you. Because maybe if you're under a DOS attack, but the proxy, it comes with the standard 200 threads. So you can have 200 threads in each OJP server by default, but you can increase that. If you want to deploy bigger versions of OJP server, you can increase that with configuration. So in the simplest example, with 3 instances of OJP server, you have 600 threads in OJP server cluster, right? To overwhelm 600 threads, virtual threads now, because OJP server only runs on Java 2021 and upper, you need a lot of load. So like you need to be like a mid to big size application already. And if you do that, then you provision more, right? Or you provision more OJP servers, or you provision bigger OJP servers, right? That can account for that, and you increase that number of threads you can handle. Obviously, if you somehow reach that limit, it will start timing out. It will send errors to the client. But those errors are error infest, so failing fast approach. They don't hit the database, so they don't put more pressure in the database. So they help to protect the database. So even if you're receiving errors, these errors are coming from the proxy and not from the database. Because when you start getting timeouts and things like that from the database, it's the sign that you're just about to lose your system, right? So it's a lot better to get a few errors and survive than to have a system going down. So that's the when you reach that critical moment of saturation. And I hope that answers your question. If there's anything I didn't cover, please let me know.
Mr. Mushud, please, is your question answered?
Yes.
Mr. Rogerio, yeah. Just wanted to ask again. Does it support auto scaling, or you have to plan it from the beginning that this is the maximum we will need to, or you can auto scale as it goes? Thank you, sir.
Very good question. You cannot auto scale the proxy, no, but that's normal in proxies. Like you're not going to be able to auto scale many proxies, and what you need to do is to plan in advance. That's for sure. Like you need to have your plan in place. You need to do your performance testing. And the thing about the OJP is that we thought about doing the auto scale, right? It's an idea that came about, but we are not sure yet if that's something that people would want to use in the proxy. Our current perception of this is that it's not needed. But if people start testing and saying like, oh, actually it would be beneficial to have an auto scaling, we're going to work on that then. Because at the moment, we think with a few OJP servers, you can handle a ton of requests, because the proxy is a very lightweight service, right? It doesn't do much. It receives the requests and send them to the database and do a few things with these requests. So it doesn't do heavy jobs. So our understanding is that it can take a hell of a load in the proxy before needing any auto scaling. But if reality proves it differently, we are ready to switch and to look into autoscaling. Because it's developed in Java, right? Autoscaling, it would be a lot easier probably than other proxies. And, we currently already have implemented when one OJP server goes down, the client, because we have the JDBC driver client, sends that signal that one OJP server went down, and the remaining OJP servers in the cluster resize their connection pool to keep the level of service. So let's say you have 30 connections across three OJP servers. If one goes down and you end up with 2, the other 2 will increase to 15 until the third one comes back and account for that. That would be helpful in auto-scaling as well, because we could reuse the same system. When you, let's say you have 3 OJP servers, you auto-scale to 4, they could rebalance the connections, because that's the concern, right? You want to keep the cap of connections stable. So if it's 30 and you insert a 4th OJP server, how much would that be? Like 6 connections, right? Per node then, to keep the 30. And currently we don't have it, but it's something that came about before. It's something that is easy in our radar. It will depend on how people use OJP server and how they report results of it. At the moment, we don't think it's necessary. And our recommendation is that you size your cluster on advance.
All right, Mr. Robetti. We have 3 more questions. I don't know if you can we leave it towards the end, or you can take them while moving on?
Let's move a bit further. It might solve some of these questions, but I would say let's move just before the demo, and then I'll take the questions if they are still in people's minds, or if they are, because there are a few slides here that might answer them. So before the demo, we can take a few more. After the demo, a few more, and if that works for you.
All right, that's fine. That's fine.
All right, yeah. Just hold on there, guys. Thanks for the questions. Amazing. They're very good questions. So just so we continue with the presentation a little bit. So this slide is about the difference on the topology. So if you're deploying a database proxy, on the left there is how you usually would scale that database proxy. So your proxy cluster would be behind a load balancer and using VIPs, right? So the problem with that is another hoop in the network, right? You're already putting a proxy, which you're already probably gonna decrease your or make it your latency a little bit worse. And then you need to put a load balancer in front of it as well, which again is another network hoop. So in many companies, people give up on using a database proxy because of that, because the topology becomes too expensive, right? It's too much infrastructure already. What happens is in some cloud providers, they do that and don't even tell you that they are doing this. I found out recently that, for example, the DigitalOcean, when you provision a Postgres cluster, they do put a PG bouncer in front of the cluster for you. But I don't like that either, because when I'm designing systems, I want to know exactly which components are being used, right? So if the cloud uses some component behind the scenes, I'd like to know that. And that's something I find that should improve with the cloud providers. They should be more open in relation to which tools they are using and to do what. Because as engineers, we need to know that. Like, we need to know that to plan our systems and to understand, for example, if they are using a proxy, that explains maybe a little bit more latency on requests or things like that. So openness is a big thing for us. That's why we are fully open source, is Apache 2.0, and all our documents are all public, and everything we learn along this way, it's public. We try to release as many articles as we can. In the right side there is our topology of OJP. So basically you have your application, you have the OJP cluster there in the middle, and the database. Much simpler, right? Just 1 second. So that gives us the ability to use this JDBC driver client to choose the healthy proxy. If some proxy is not healthy, it will not send load to that. It can automatically retry and failover. There is no need for an external load balancer or VIP. And you get your high availability without any extra infrastructure. And the extra infrastructure is the load balancer. And here we are so simplifying because normally it's not one load balancer, right? Because you cannot have one. You need two. And then you have two load balancers with VIP in front of your proxy cluster. If you're in a cloud provider, the cloud provider will provide you that at a cost, right? Everything for a price. So it is easier to do, but it doesn't make it less complex. It's just you're paying for that complexity on the cloud provider. So we try to reduce that. Because we produce the JDBC driver, we can do this load balancing and failover in the driver. We don't need external tooling for that. Here's just a representation of some languages that could compile our client and could communicate with the OJP server, just so you see that it's not just for Java. In the future, hopefully we can produce clients like we have the JDBC client for Java, clients for these other languages, so other languages can also use OJP. A quick pass through the circuit breaking, right? So how the circuit breaker works. That's mostly for people that might not be familiar with a circuit breaker. So in a normal scenario, all the queries are flowing from the app to OJP to the database. They're all green. But if one specific query starts failing and it fails repeatedly, by default 3 times in a row, OJP will block that query and will send the last exception received to the client. So it creates a fail fast scenario here. It does not send that query again to the database. That's very good for queries that are poison, queries that fail consistently and they never work. But it's also very good when you are, again, in the brink of collapsing. Because when you're in the brink of collapsing, what happens is these low queries start failing with timeouts first. And they fail repeatedly. But if you keep sending those heavy queries to the database, you're basically adding on the pressure that may end up rendering the database unresponsive. So by blocking and creating this extra protection to the database, you might be saving the database, okay? So once a period elapses, by default 1 minute, but you can configure it for more or less, it will send one of those queries again to the database to see if the query is now working. And if it's back working, it goes back to green. If the query fails one request again, it goes back to blocking, waits another minute before it tries a test query to the database again. So that's an extra protection, is our implementation of a circuit breaker, and it helps again as a second layer of protection to the database, besides the limitation on the number of connections. We did some performance testing. I'm not going to be here too much because this performance testing proved to be a bit misleading, but it does give an idea of how OJP helps. You can see there in the graphic that with OJP, the database used a lot less CPU, which is the target, right? The CPU is a core indicator of how much the database is suffering to respond to requests. And throughout the test, even the latency was better with OJP. What we found later is that we were putting a lot, there was a issue on the test that the connections were not pulled in the test without OJP. And because they were not pulled, like that created a big difference. We did do this test again with a connection pool, without OJP and with HIC-RCP on the client. And the results were much better for the JDBC side, but it's still at around 150 threads. OJP was performing better than without OJP, even using a connection pool. So don't look too much at these numbers. They are a bit misleading. What you can look safely is that in the right side there, OJP is very stable. If you look at the average duration and the increase on threads, you see from 1 to 200. The average response time of OJP is stable all the way. And that's not true when you don't use OJP. even though this test was skimmed because we didn't use a connection pool. Once we did the test with the connection pool, still at 150 threads, OJP became faster than without OJP, which is because the database can concentrate in doing work instead of switching context, right? That's one of the main things. Yeah, let's take a few questions now before our demo. I think there was a couple questions queued.
Yeah, okay. Mr. George, please can you come with your question? Yeah.
I think he answered my question when, hello.
Yeah, coming out clear.
Yeah, I think he answered my question because my question was if we can load balance before OJP. So he already answered my question. And I also have maybe another question. How can we avoid single point of failure? It's something that was in my mind before the load balancing came out.
You avoid the single point in which layer? In the application layer? I assume
in the proxy server. The proxy server.
Yeah, because we can deploy. You see that graph in the right side there. You can deploy a pool of. I will not use the word pool. A cluster of OJP servers, right? In that example, there is 5. So it's not a single point of failure anymore, right?
Okay.
So we have 5 of them. We recommend at least 3, and the 3 is mostly because it's a general recommendation, I think, for operations, right? Like you should never use 2. 2 is too little, but depends on your size, right? If you're a small company, you probably find with 2 or with no proxy server at all. Like depending, if you're a small company, that's something that sometimes I get asked, like when you should not use OJP. If you're small, I don't think you need a proxy, okay? But if you are developing or designing an application that needs scalability, then is when you start looking at these things, right? In relation to the single point of failure, very good question, because this slide is what shows the big difference between the traditional proxy landscape, which is on the left, where you can put a cluster of proxies, but then you need to put a load balancer in front of it. And because you put one load balancer in front and you don't want to have a single point of failure in the load balancer, you need a second load balancer at rest, which is the same size as the first one. And you see how complex this starts becoming, right? And you need to manage all that. Put on top of that, if you have multiple databases, this proxy solution is different, right? So let's say if you are using Postgres, probably you're going to be using PG Bouncer. If you're using MySQL, you're going to use Proxy SQL. But then it's 2 proxies, and you need to learn everything about those 2 proxies, and they're different. They are not the same. They don't share any specification. So that complexity just grows and grows, right? You could use the proxy of the cloud provider, like AWS, but then you start becoming tied to that cloud provider, right? And that's something you don't want to be. You don't want to be too tied to a provider. And if you start using all the solutions on a cloud, you end up like, if that cloud increases their prices, suddenly you're a hostage, right? We as Java developers, we like freedom. We use Java because Java started with write once, run everywhere. We like freedom. So I think we never get at ease being locked into a single solution. We like things that give us the freedom to move around if we need. So in relation to the single point of failure, which is the question, I diverted a bit. Absolutely, yeah. Our recommendation is minimum 3, no single point of failure there.
Okay, thank you. Thank you.
Thank you. Thank you for the question.
Thank you very much. Okay, Mr. Dashon have a question for us.
Yep.
Mr. Dashon, you can go ahead. Yeah.
My questions were similar. They've already been answered. Thank you so much.
Very good. Very good. Thanks, Dashon. The demo, the part that the developers like the most. Let's bring the code. So what we're going to be doing for this demo, guys, is we are going to be, for some reason, when I decrease the size of this, it always go back to the other screen. I don't know why. Okay, can you see my code here, my IntelliJ? Hope we can. Is that a yes?
Yes.
Okay, so this is a Spring Boot project, guys. You can find this in our repository. We have multiple repositories under the OpenJ Proxy organization. So one of them is OJP framework integration, and there we have integrations for Spring Boot, Micronaut, and Quarkus at the moment. And we are planning to expand that to other frameworks. But these are the most used frameworks in Java, right? So we felt that those were the first ones to start. And this is one of the little projects we created there. It's a shop service written in Spring Boot framework. So if you ever wrote a Spring Boot app, you're going to be familiar with these divisions. You have your controllers here. You have your entities here, repositories, right, and the application itself. And we have some tests here, which we're going to be using. For example, the order item controller IT is an integration test that uses H2 in-memory database as database. OpenJ Proxy does support H2 in-memory database. We use it largely for a lot of our integration tests because it's very easy to to set up and to run. But we do integration tests with many databases. We do Postgres, MariaDB, MySQL. We do Oracle, SQL Server, DB2, and CockroachDB. Those are the ones we test every time we commit to our repository. Now, what we're going to be doing here is the reverse engineering. Usually this test runs with OpenJ Proxy, so I removed it from this application, and currently it's running without it. So what we're going to do here today together, we're going to start with an application that works without OJP, and by running this test and getting all green, we know that it is working, it's functional. And we're going to go through the documentation of OJP, and I'll show you where you can get started if you want to try OJP. The first thing you're going to do, you're going to come to OpenJ Proxy OJP repository. If you want to see the other repositories we have, they are here. Just very quickly, OJP is the main one, right? So right at the top there. Our website is here. And the frameworks integration that I talked about is here. If you're deploying to Kubernetes, this is an interesting one. We can use Helm charts to deploy to Kubernetes. And this has been created. It's not in use yet. It's if we decide to create an enterprise version, but at the moment, it's not used at all. So what happens is the first thing you're going to do here is to give us a star, right, in the repo, don't forget. And in the very first page, it already tells you how you can get started, right? The quick start here. The first thing you want to do, you want to start the OJP server. Using Docker container, you can start like this. So what we're going to do real quick here, let me get up a console here, terminal. Let's clear it. And so from version 040 beta, you're going to have to download the drivers and put it in an OJP libs folder and mount that OJP libs folder into the Docker image. We did that because initially we were packing with the open source JDBC drivers, but that proved not to be good because some people use different versions. So the server was too big because it was packing with drivers that it didn't have to have. That's why we removed. It doesn't pack with any drivers now. So you need to download your drivers and put it in that lib. Because we didn't release yet the version 040, actually this version 032 beta, you don't need to do this. But if you do, it's not going to make any change. So it's better to get used to what is going to be the next version, which will be released by half March, probably. Around half March, you're going to be releasing this. The code of the 040 beta is already in the main branch, so it's just waiting for the release date at this point. So the first thing you're going to do, you're going to run your OJP server, right? We can copy this. I'll try to follow like what would be, like one of you would be doing, right? So you're going to run this. And then we have a OJP. Oh, hold on a second. This is not right, because this Postgres here is a different, it's Postgres running. So there was a problem running this. And let's see. Let's see how I ran the last time. It's a weird one. And try again. Maybe it's the yes. For some reason, it's not starting. That never happened before, guys. Let's debug it. So I think I know what's going on. Yeah, it's trying to mount this. Apologies for that. So it's trying to mount the OJP libs, but I'm in a folder that doesn't have it. So let me just find here. So with demo. I think I have a demo folder here. Yeah, I do. Demo. What I did in this demo folder, I created an OJP libs folder with mkdir, right? And inside that OJP libs, I currently have just the H2 JDBC driver. You could have as many drivers as you need. If you're using more than one database, you can put as many as you need there. If you execute the same command now, it should work. That's a bit annoying. Now we do have WD should come to this, because the idea is that you have the libs here, the libs mount into that guy. Why is so the PWD OJP libs? Am I missing something here? I did this 2 days ago with another group. It's weird. I need to look into this. Probably the documentation needs to be updated. Because once you're running from a folder that you can mount the jars into the OJP server. I'll try just once more. If this doesn't work, we'll do an alternative approach for this then.
It's okay. We're fans, and some of us, I'm looking at myself, are a bigger fan of troubleshooting demos than product demos. Seeing how you work through when things don't go right, sometimes that makes the big difference.
Yeah, this one I'll have to debug with more time, because you see it's not coming with an error. It's saying it's basically saying that it created a container, but the container dies just after it starts. So I'm imagining it's because of this. So I'll remove the factor that because the version, as I said, the version.
Have you checked if anything is running on any of the bots?
That's a brilliant. Actually,
this community is awesome like that. We like to troubleshoot together.
That's exactly what's happening, because before this call, I was programming, right? And I have a server running in my IntelliJ. It's just not in the screen. I just killed it. Very good, very good, very good. I love the community. Yeah. That surely is the problem. Very good call. Very good call. Yeah, it took longer. That's a good sign usually. There it is. Yeah. Thank you. That was great. Whoever, what's your name there? The one that they called the port right away?
George. It's George.
Nice one, George. That's brilliant. Good pair programming there. So you see, so this should work for you. just be careful, like if you're using copying from there, make sure you have the OJP libs folder, right? Because that could cause a failure as well. Because basically you're saying here, like in the current folder, I have an OJP libs. That's why I thought initially that the problem was that. And I do have a demo Spring Boot folder that already has the OJP libs with the H2 in there. Now we have our OJP server running. What we're gonna do next is we're not gonna run it as a jar. No need to look at that. For an initial run, I recommend you using Docker as the fastest. We're gonna use the driver in our application. So we need to get this guy, and we need to put into our home XML. Right? It's already here, but let's pretend that it wasn't, and let's put the driver there. Now, in IntelliJ, usually it's best to reload the dependencies to make sure they come to memory. Let's follow the documentation, because I find it always useful to follow documentation. It helps me to spot bad things in the documentation. So the next thing is a very important one. Like, we don't ask you to change many other things outside of what you already configured. For example, you already have a URL for the database. What OJP does is that you just need to tell where the OJP server is. So you just need to prefix your URLs with the OJP location. In our case, it's localhost, right? But it could be an IP or a DNS, etc. And the port. The default port is 1059. And then the rest of the URL remains the same. It's just a little prefix that you put, not really a prefix, but a middle fix, let's call it like that, that you put just after JDBC call. And that's what we're going to be doing next. I have a little file here where I can copy the two ones we're going to be using. And to do that, we're going to go to our application properties, right? In Spring Boot, there is where we currently we have the connection URL for the H2 in-memory database. We're going to put this guy with a name. So this is our high-performance data source. In this example, we have two data sources, right? It's already not this most simplistic example. I use it for demo because it already shows that OJP can handle multiple data sources. But if your application has just one data source, it would look more like this. You don't need to put a name. And I'll show you in a second what that name does for us, because then we can basically configure two different connection points, one for each name. And this guy is going to be the default. If you don't give a name, it's the default data source, right? So this guy is the default data source, and let's say this one is the high performance data source. That's done, so our URLs are changed to the OJP format, and we need to change the driver as well. That's the basic changes you need to do. But because we are working with Spring Boot here, there is a few things that are related to Spring Boot framework that we need to do. If you're just using a Java application, with these changes you could run already against OJP. But because we are using Spring Boot, what we're gonna do is that we're gonna use another documentation here, which is related to framework integration, right? So let's just find it here. Yeah. So Java frameworks. So let's look at the documentation for Spring Boot. Here it is just repeating, right? We already put the dependency there. Now, because the Spring Boot starter, JDBC, it comes with HIC-RCP embedded in it, we need to exclude the HIC-RCP. Why do we need to do that? We cannot have another pooler when you're using OJP. OJP takes the connection pooling job, so you cannot have a pooled pool. In our test, it created trouble. Like, it's surely gonna create you a lot of trouble, because then you have two connection pools trying to manage the connections, and it becomes a mess. Like, for example, how are you gonna configure to time out those connections? How are you gonna configure the max lifetime of connection? How frequently the connections will be validated? there's two pools trying to do all those jobs. So not a good idea. Don't do that. So let's go back here in our from XML. Let's find our Spring Boot starter JDBC, and we're going to put an exclusion there. And that exclusion is to exclude HIC-RCP. Now, because we excluded HIC-RCP from the Spring Boot starter, that also excluded the standard JDBC data source that the Spring uses. So we need to give a different one. But that's very easy to do. All we need to do for Spring is to put the standard simple driver data source. So if we come here, we'll just add one more line here, and we say that we're going to be using as a data source the simple driver data source. What that does is that it doesn't use pooling at all. Whenever you need a connection, it creates a new connection. You know, OJP is a virtual connection, so it's super cheap. And whenever it finishes with the connection, it closes in the connection. With 4 OJPs, the signal that the OJP server can release that connection for another process to use. So it's very important that connections are created and closed when using OJP. And here's it's the same thing, just different data source, right? The Spring data sources, they are called catalog and checkout. The OJP data sources, this is the full OJP data source, and this is the high performance data source. Now, because we have two, I'll show you also how you can configure both. So to configure both in the resource folders, we're going to create an OJP properties. And in that properties, then you can put your configuration, right? Which I'll copy here just to make it faster. But basically, this is all in the documentation as well. You're going to be doing the same configuration as you would do in any connection tool, right? Max pool size, minimum pool size, connection timeout, and any other things you want to configure. Because we have two data sources, we use a prefix to name them. So you see the high performance one here is the one that is going to be used here. That's how you link them. And the other that is the default one doesn't need any prefix. You just configure like this. All right, two data sources are there. Let's go back to our documentation. Let's see what else. We already changed the URL. That's fine. And here there's some troubleshooting if you experience any of these issues. And I don't think we're gonna. Let's do a test now. So as we have our OJP server running in Docker already, we did these changes here. If we run, we should see all green on these tests, right? And they are the same tests now running through OJP. You can see there that it's using the OJP driver already. Yeah, success. And just to be sure that was the case, trying to do fast makes me slower, isn't it? So we're gonna kill the OJP server, right? And the test should fail now. And that's just to show that it was really going through OJP server, just to validate that assumption. So when we try to run this, it should fail. Yeah, and the failure should be something, yeah, unavailable. Unavailable meaning the OJP server is not there. That's the demo, guys. If there's any questions about the demo, please fire away. We have large amounts of documentation, so it's very good if you're starting to come here and to look. There's very good information here. We recently released this ebook, all free, is all in here, so you don't need to download or anything. You just come to our repo. All the information about OJP is here, from the architecture to how to do it in Kubernetes. There is large amounts of information here.
Fantastic. I am going to just jump into a few things. I'm very biased. I made a joke that other people use frameworks besides Spring. Haha. I'm on the Spring team. So I immediately wanted to say, is there a Spring Boot starter?
But we would love if someone would make one.
I made a update to one for ngrok. ngrok has a similar starter where when it starts up, it actually looks for the proper driver, the proper like binary to download. So that I was thinking in my head, maybe you could do that same thing with the drivers here, where the starter could just look at the properties and download the drivers, just to make it so that it would also help out the upgrade process, right? When you upgrade the property to the new driver version, and your starter takes care of it. And then the extra part where you went to the documentation and said, hey, you're using Spring Boot, you've got to exclude this Hikari connection pool. Mm-hmm. I worked with a team over at Oracle. Have you ever heard of Open Rewrite yet?
No.
Open Rewrite is a framework written by a friend of mine, Jonathan Schneider, where it can actually, in the starter, we could make it so that if you've got the starter in place, the starter could actually go and modify your POM or your build.gradle for you. You know, without it's still going to show up as a diff, but it could go and update. If you see Spring Boot Starter JDBC, it could go and update it automatically if you have the OJP starter in there. So there's just a couple of ideas that I was thinking as I watched, and the final one was again, I'm biased and I have opinions. In my head, the container that we would use for OJP, the container that I would build for an OJP server that only has 30 connections, I'm going to size that one different. I'm going to give it different parameters. I'm going to give the JVM different properties than one that has 1,000 connections.
Yeah.
So I was thinking that maybe a build pack would be a good idea there, where I could programmatically have a cloud native build pack that looks at the properties of the actual project that you're building it for, the OJP server that you're configuring. So that it could right size that OCI image. That's a very Bruno Borges thing from Microsoft. That's one of the things I've learned from him about right sizing those containers and setting them up properly. Because a container that...
Yeah, I know Bruno.
Yeah.
Bruno knows about this project.
Yeah. And I think
Bruno is a fellow Flamengo supporter.
There you go. Yep. I think I've seen you present with Bruno once, and maybe also Kat Edelweiss.
No, I don't think so. I don't remember presenting with them.
Okay.
I may have been in a call with them. Was it a call at Oracle? Maybe an Oracle call, because they were at an Oracle call.
Well, I'll say that I learned about this first from Kat over at Bellsoft. I learned about this project first from her, and then when I heard about it from Bruno, that's where I got really excited about it. So yeah, this has been on my radar for a long time. Yeah, and I don't know if I'm the one that asked you to come here.
Yeah, Kat is Catherine from CyberJar as well, Bellsoft,
yes.
Right?
Yes.
Yeah. Exactly. Yeah. No. I presented at her channel already a couple of times.
Yes.
She's a big supporter of the
Yes. Project. Fantastic. So thank you so much for coming. This was solid.
Look, if you can reach out to me, it's hard for me to take notes now, but let's put this in notes. Let's put this in a discussion, and we can go through these things, and surely we can get both started. We recently updated our roadmap, so this wouldn't be in our official roadmap. So our roadmap for this year is this. But honestly, it all depends on people that join the project, because like yourself, there is many people that love Spring Boot, and I know that people that love Spring Boot, they love their initializers, they love the auto-configurable things. People don't like to be doing all these manual things, and it would be great if someone could take this. Maybe we can formulate the idea, create some issues about this, and leave there maybe someone comes in and start getting this developed. Our roadmap for this year, so as I said before, we are releasing the version 0.40 beta mid-March now. That will have an implementation of calcite. The main implementation on that version is the service provider's interface. What that allows you to do is that we use HIC-RCP, and we implemented in this version also DBCP as connection pools. But with the SPIs, you can implement your own connection pool. Again, more freedom, right? If you want to use another connection pool that we are not supporting at the moment, you just implement the SPI, and we will support both for XA protocol and non-XA, local transactions as well. A few more things. It will improve quite a lot in telemetry as well. This the programming I was doing just before is related to metrics, improving the quality and the number of metrics we need, and a few other things for March. Then June, July, we plan to release read and write segregation and caching. So at least a reliable implementation of this for version 0.50 beta. And by September or October this year, we plan to release the 1.0 version, which is the long-term support version, the first ready for production version. That doesn't mean that you cannot use the beta version in production. These versions are being heavily tested at the moment, but the official 1.0 should come later this year. There's a few considerations here. We can add your suggestions in our, not in the roadmap, but in our discussions. We have a few discussions going on, and we surely can add it there. Really appreciate it. The second time we get this about Spring Boot, I think is a recurrent one. And if you have the time and can reach out to me on LinkedIn, I would love to talk further out of this call with you.
Absolutely. I will try to connect with you on LinkedIn or other ASAP.
Lovely. Appreciate it. So again, just in relation to documentation, as we were saying, like we have this helper page that help you to get started. If you are in our homepage here and you go again to our documentation and the frameworks page, Java frameworks. Here you have all the three frameworks we currently have documentation for, but basically it's three steps. You need to remember that these three steps, they never change no matter which framework you're going to be using. You're going to modify your URL, you need to remove the connection pool that the project is using at the moment, because OJP will take over that job. And you need to add the OJP JDBC driver. Those are the three core things you need to modify in your application. And then for each framework, there is one caveat here or there to do these three steps, but it's just three steps, okay? Moving forward, our slow query segregation, and what that is. If we were talking that having a connection pool, you want to have a limited amount of connection. What if you have slow queries that take long to execute? And let's say you have 20 connections, and at a given time you have 20 slow connections. Like in a highway, you have 20 trucks in front of fast cars. How do you solve that? That's a scenario that was never attempted to be solved by any proxy. So I believe we are the first to be trying to solve this. Is for scenarios where you have mixed load, you have the fast queries in the same, competing with this slow queries in the same pool. And the solution we created for that is basically a smart bulkhead approach, which look more or less like this. Right? If it was a highway, we would separate the lanes of the highway in fast lanes and slow lanes, or fast queries and slow queries lane. By default, it's coming enabled at the moment. From the next version, will be disabled by default, but you can re-enable it. Why are we disabling it? Because again, this only makes sense for mixed loads. If you have only slow queries, or if you have only fast queries, there is no reason to enable this. But if you have scenarios where there is a mix, what this will do, it will measure the average response time of each query in the system, and we will allocate the query in specific lanes in your connection pool. So the slow lanes for slower queries, the fast lanes for quick queries. So even if you have a connection pool of 20 connections and you have 20 slow queries running at the same time, they will not take over the pool. They will only take over the lanes that are allocated for slow queries. And these lanes can be borrowed for each side. So if one side is not, let's say the fast queries are not fully being used, then you have a lot of slow queries at one given time, where these slow query lanes can borrow lanes from the fast queries. It just cannot borrow all of the lanes. One lane needs to remain in each side at all times. But that's why we don't call it just bulkhead, because it's not a simple bulkhead, right? And we call it it's a low query segregation solution for OJP, but it's basically a smart, adaptable bulkhead solution, which uses also still work principles to do that with a very lightweight measurement system to measure how quick these queries are. Because that's what was another concern. We didn't want to put any heavy measurements to do this. We wanted a simplistic approach to how we measure and collect this data in relation to how fast the queries are. So this is an interesting one. It doesn't exist in any other proxy, only OJP. It's a very novel thing to use and to test for mixed loads. Towards the end now, guys, very, very quickly, if you want to help the project, and we have one gentleman already that contributed some nice ideas about Spring Boot. If you have ideas, if you want to help just to advertise the project, Victor has been an amazing helper. Like, he organized this meeting. He has been contributing in many fronts in OJP. We are really thankful to him, to his work, and the other volunteers. So you can start our GitHub. Obviously, that help us, right? More stars means more visibility for developers. Try it yourself, test it yourself, report bugs, report inconsistencies in documentation, update documentation. There's many ways to help. It's not just code. If you're like, I understand that sometimes code at a proxy level, the code can be a bit intimidating, especially in the beginning. But we have some more simplistic tasks at the moment open that can be tackled by like new developers that are not familiar with OJP. But we have a lot of work in other sites. Like, we need people writing articles, making content, doing presentations. We need people sharing in social media about OJP. So all that helps the project. If you have money to give us, we accept money as well. There is a little link in our repo that receives donations. We have a Discord service server. You can join the Discord server if you want to know the news early, like our discussions. You can join also our bi-monthly meeting about the project. LinkedIn page, if you can, please follow us on LinkedIn page. We don't post a lot. We post every week, but not every day. So you're not going to see loads and loads of posts, and we try to keep relevant. So we always post interesting things there. Then my X account there as well, if you want to follow me personally. And I don't post only about OJP, but mostly about OJP, obviously. So that's something. The QR code is for the Git repo. If you want to do now, give a star, you can scan that. Another thing we do, this is a very cool thing, in my opinion, is the contributor recognition program. So we basically rip off the Java champion name, right? And we call our OJP champion. And we are not the first to do that, because we have Vadim champion, IBM champion, Java champion made children, let's say, like that. So what we do here is that every time you help the project, you might be getting these badges, right? The ones at the bottom here, they are easier to get. Basically, any help you give to the project, you get one of those. So they're entry-level badges. And as you advance up, they get harder to get until you get the OJP champion, right? Which requires like sustained long-term contributions to the project. It requires you, to engage for a long term. But let's say if you have only once, or sometimes you share things about OJP, you already get recognition from these other badges. And this is cool because it allows us to give recognition to people that don't contribute code. Because code, if you contribute code, the GitHub already rewards you, right? Because you are recorded as a manager of the code, your commit is there, your name is there, right? But we wanted a way to put the names of the people that help the project here visibly, and that they can share in, in their CVs, in their social media, in LinkedIn especially, put there like that they are contributor of an open source project, and they can use these little badges to show their work in their profiles, websites, etc. So we have 4 lanes. Code is obviously the first lane, right? We are a software project, but also test and quality. Like if you help to test it, you report bugs, you help to build new tests or things like that, you can get the green badges. Evangelism and community, if you're helping to advocate about OJP, bringing the OJP forward, like Victor did by helping Victor sharing about the OJP, creating this meeting, so that falls into this category. And the 4th one is documentation and content. That's more related, like if you feel that your strong is writing, you might start by writing or reviewing documentation of OJP, improving documentation, authoring articles or blog posts, etc., and growing that lane there. OJP champion is the final one, right? It requires long-term commitment to the project. Here are the rules, and here are the people that are awarded. So if you help, your name can be printed in this Hall of Fame of the project. And sorry, let me just go one more. And the last page is, I'll take more questions in a second, but just I removed this introduction about myself from the beginning, because I find that the most important is to present the project and not myself. But I'm a father of 2 boys. I'm postgraduated in software engineering. I've been doing software engineering for more than 18 years. You can see some companies that I worked for there, like MasterCard, Huawei, Citibank, Bank of America. Currently, I'm a lead software engineer at Bank of Ireland. I have a certification on TOGAF. I have 4 more certifications on Java, the old ones, the programmer ones, the ones that web developer, all those old ones, AGB, those kind of things. I'm the OJP founder, right? And currently that's what takes most of my time and my effort outside of my work and my personal life. I'm the author of the design parliamentary proposal for auto-scaling stateful systems, which was an article published by InfoQ in 2023. And I'm a blue belt in Brazilian Jiu-Jitsu. I think that's my hobby. Whenever I have time and energy, actually that gives me energy. So that's my hobby. That's something I like to do to keep fit. Any last questions, guys? And that again is the GitHub there. If you go there, please do give us a star and follow us on LinkedIn page. I'll take more questions now. If you're not, we can start wrapping up the meeting.
Yeah, more questions, guys. So anyone have a question, please can we go ahead and ask.
I missed the original list of the databases that you supported. I came in right after you'd done that. What's the list?
That's an interesting question. I don't think I have a list in this presentation. Let me double check. I don't think that's a good thing to add a list here. So we can support any database that with a JDBC driver, right? And let me also see if we do have here. I think it's something you gave me an idea now. It should be more clear here in the first page, which is not. It's probably in some other page, but I'll mention to you by heart. So we support Postgres. From the open source ones, we support Postgres, MySQL, MariaDB, right? Which are the most used ones. We support H2 for in-memory testing. We support Oracle, SQL Server, and DB2. They're listed here a bit hidden. And we do support CockroachDB as well. And that's all tested via integration tests. So we have almost 1,500 tests at the moment running in our pipeline. So I think it's even better if I show you the actual one of the actual runs. Every time we commit to our branches, we run let me just see one merge here to these failures are from branches. They are not from the main here is one in the main branch. This one failed for some reason, but it's green at the moment. So how our test works? So we start with an H2 test. Let me see if I can increase this. Yeah, that's much better. So we test with H2 for different versions of Java, Java 11, 17, 21, and 22 at the moment. And then if those initial tests pass, we start then testing all these databases that I mentioned to you. Also with all the, it's a extrapolation with the JDKs, right? So every test runs 4 times for each JDK. So if we look here, it goes cockroach DB2, Maria DB. There is a test for failover, multi-node integration test, multi-node integration with the XA protocol, MySQL, and it goes on like that. Oracle, Postgres, and finally SQL Server. So those are the database we support by testing them. And there was a very loud noise there. But again, in theory, we can support any database that has a JDBC driver. I would not be surprised if we just throw a JDBC driver into it and try to connect to a database. In most, like 80% of the functionality works out of the box, or 89%. There might be some caveats. The caveats we found between databases are usually related to streaming of large objects like blobs, C-lobs, things like that. They differ quite a lot between databases, and something like that, like the basic, setting an integer, setting a parameters probably will work out of the box. Okay. Is there any database you would be interested that is not here, or anyone in the call?
Greenplum. I have a hot use case for Greenplum, and we can talk about that next week.
What's the name of the database? Sorry.
Greenplum. It's a Postgres compatible.
It will work out of the box there. Because
yeah,
you see,
I'm hoping.
You see, 100%, because Cockroach is already a Postgres wire database, right?
Yeah.
So
I was on mute, but I clapped when you said cockroach.
Yeah. So we wanted one of these modern ones, like because we do support the traditional ones, but we wanted at least one. And Cockroach is one that I've been an enthusiast myself, even though I don't use it. I work for banks, right? Banks is all about Oracle, DB2, and those things. But yeah, Cockroach is an interesting one. Reach out to me, please, and let's talk about the. But the expectation is that you will. Once you respect, that's a good point. I should probably change how I explain this. We are compatible with wire protocol, right? So if you respect the wire protocol of Postgres, most certainly we work with OJP. Even if you have a new wire protocol, let's say you're using an old version of Sybase, which was later, I believe, acquired by Microsoft, and now it's SQL Server. They support Sybase, but it's a no thing, and it probably gonna work. Now there is this caveats of here and there. For example, there was one caveat related to SQL Server, that there is one date that SQL Server uses that is not a Java date. I don't know who approves that to go into their driver, but it's something that I'd like to talk to the guys on Microsoft at some point. Like, I understand that at the time the dates in Java were lacking, functionality, but they put a date there that's not from a Java package, and that created trouble for us, right? Because we had to adapt that date into something else. But there is these small nuances, like if you use a specific date that just the database uses, or if you're using large objects, that's a minefield, all right, that could work, could not work. But all the rest, like if you're creating connections, you're creating statements, prepared statements, reading result sets, like all the bread and butter of JDBC, most probably going to work out of the box. I'd love to hear your experience with this database that uses those wire property. That would be lovely to hear. All right. If no more questions, guys, I'd like once again to thank you for coming in. It was a real pleasure to talk to you. Brilliant questions, like high level, very good questions. Not just high level, like many good questions to clarify things as well. Because we need both, right? When you're presenting to a group, like you're always going to have questions that are very deep and questions that are more basic in quotes, right? But those are the most important as well to resolve, because people then feel confident to use it and to start using the solution and the project. So thank you very much. It was a pleasure. And thanks again, Victor, for organizing it. It means a lot to the project and to myself.
Thank you very much, Mr. Robetti. Please, I would like to use this moment to kind of, if you're not on our social media platform, or you're not following any of our social media platform, the WhatsApp, the LinkedIn and the X is posted right in the chat. So you can just click on it and follow up with what we are doing on WhatsApp, on LinkedIn, and on X. And also, I want to appreciate everyone present here for making our time to be present in this very section. I truly appreciate you. Your being here, your time matters a lot to us. Your contributions matters a lot to us. So we truly appreciate, and let's keep the Proxy power boosting. I'm already feeling Proxy tonight. I'm feeling the power of Proxy. So I would like to use a few minutes to appreciate Mr. Dashon for being here today. Your presence is highly recognized and welcome. Please, I would like you to maybe use a minute or two to kind of talk to the community and kind of give us your words, because you have always been with us right from the foundation before we call it a day.
Yeah, as always, I'm just happy with this group. I'm happy with the progress that we've made. Today was an absolutely amazing presentation. Clearly somebody that knows what they're talking about, able to handle all sorts of questions, all out of order with people coming in. So yeah, just this community is trending in the right direction. And the thing that I've been saying all along, we have to be continuously learning what the ecosystem looks like and how we're going to move forward. And yeah, everybody that was here today got leveled up for sure. Keep up the good work.
All right. Thank you very much, Mr. Dashon. Mr. Robetti, I don't know if you have anything more to say before we call it a day.
I have one question for you guys. What's the traditional food in Nigeria that I should try for sure? And I'll try to look it up. Try.
Oh, Miss Gloria, please, can you help us? Nigeria traditional food. Miss Rosemary is here.
You didn't expect for that one.
Yeah, we have people who can give us a good. Please, Rosie, can you please help us with some Nigerian?
It doesn't need to be traditional. It can be popular. Traditional or popular, or both.
Oh, hi. First of all, I would like to say it was an amazing section today. Thank you very much for having us. For Nigerian food, the first on the list is the Nigerian jollof. You should try that.
Jollof.
Yes. Then egusi and fufu. Very nice. You wouldn't want to miss out on that.
Fufu. I heard about fufu before.
Fufu is nice. It's nice.
Yeah,
Yes, then
I'll try to find it.
yeah, you can try Nigerian suya as well. You love them. Thank
Yeah,
you.
we have a market here that has international foods. I'll surely look it up. Thank you, guys. I really appreciate. I really appreciate, especially the food tips. I'll look it up, and I hope some of you try OJP. And if you have comments or questions, like we're always on LinkedIn, on our Discord, and the community is very open to help. Everyone is very happy to support you in any questions you might have after. Oh, very good. Someone sent the actual names there. I'll copy to make sure I don't lose.
All right. Thank you very much, Mr. Robetti. I truly appreciate your time here and everyone present. Okay, go ahead, Miss Rosie.
Okay, I was wondering if maybe he can drop his LinkedIn and everything here so that we can follow.
Yeah, absolutely.
Oh, okay.
Let me do it right now. So what I'll do, I'll drop my LinkedIn. Yeah. Just give me 1 second, because when you need to do things in front of people, is always much slower than you expect, isn't it? Yeah. This is my LinkedIn here.